So this is problem 8 of the Aime. Let z1, z2, z3 to z12 be the 12 zeros of the polynomial z to the 12th minus 2 to the 36th. For each j, let w sub j be one of z sub j or I z sub j. Then the maximum possible value of the real part of the sum from j equals 1 to 12 of w sub j can be written as m plus square root of n, where m and n are positive integers. Find m plus n. So first we'll find the zeros of the polynomial, which isn't that hard. Z to the 12th equals 2 to the 36th. So z equals the 12th roots of 2 to the 36th, which is equal to 8 times the 12th roots of unity. The 12th roots of unity. So to make it simpler, we'll consider the 12th roots of unity and then multiply everything by 8 at the end. So on the unit circle, the 12th roots of unity are 1, negative 1i, and negative I, and then 2 other points in each quadrant. So if we say z equals a plus bi, then the real part of z is of course a, and the real part of iz equals negative b. So let's consider which of these numbers have an a value that is larger than the value of negative b, and this is a and this is b. So obviously this point does have its a value is 1 while its negative b value is 0, and this point has 0 a value and a negative b value. So actually, if you look carefully, at this point the b value is larger than the a value is square root of the a value is negative 1/2 and the b value is negative square root of 3/2. So this is here, and then over here the a value is square root of 3/2 while the b value is negative 1/2. So this is also included in those values. So we can draw this line where the 6 points on this side have larger a than negative b values, and those on the other side have larger negative b than a values. And by symmetry, the sum of the real parts of I times these is the same as the sum of the real parts of these. So we can then just find the sum of these 6 points, of the real parts of these 6 points, and then multiply by 2 and then again by 8 to get our answer. So the real values of these are as follows. Here we have square root of 3/2, then we have 1, then we have square root of 3/2 again, then we have 1/2, then we have 0, and then we have negative 1/2. So then if we add these, we get square root of 3 plus 1. So we multiply by 2 to get the sum of these as well, and then multiply by 8. So in the end, we get 16 square root of 3 plus 16. But we want it in the form of square root of m plus square root of n. So we put this 16 under the square root sign. So this would be square root of 3 times 256, which is 16 squared, plus 16. And so 3 times 256 is 3 times 256 is, hold on, $768, and if we add the 16, it becomes 784, which is the answer.